The next topic is stretching in stereometry. This is actually something we looked at already in the third class when looking at similarity. When we understand how stretching works, what effect it has in stereometry, it simplifies many of the tasks. Well, read this section here on your own, and we get to the next page where we see the conclusion, which simply says that if a solid is stretched by a factor k, this means that all the lengths are stretched by factor k, the areas are stretched by factor k squared, and the volume is stretched by factor k to the power of 3. So let's look at some examples to understand how this functions. Read this example here. We build a pyramid with stones, and the question is, what part of all the stones is needed to get up to half the height of the pyramid? So try a guess for yourself before you continue, and then in the end let's compare with what you guessed now. Since the number of stones needed is proportional to the volume, the question is what part of the total volume of the pyramid is in the upper half and what part of the volume is in the lower half. The small pyramid here and the original pyramid are similar, and h dash is just half of h. And so the stretching factor from the original pyramid to the small pyramid is 1/2. Since the factor by which the volume changes is k to the power of 3, we get that v dash is 1/2 to the power of 3 times the original volume, so 1/8 times v. This lower part of the pyramid, where the top part has been cut off, is called a frustum of a pyramid, in German ein Pyramidenstumpf. And we find for its volume that it is obviously the volume of the original pyramid minus the volume of the small pyramid, and we get that it is 7/8 of the original volume, or 0.875 times the original volume. Hence, already 87.5% of all the stones are needed just to get to half the height of the pyramid. I think that probably very few of you guessed that such a huge percentage of the stones would be needed for the first half. Now try this example on your own, which is just the opposite of before. Before we were given that the height of this frustum, of this bottom part, was half of the top height. Now we know that the volume of the frustum, of this bottom part, is half of the total pyramid, and we want to know at what percentage of the total height of the pyramid are you when you have used half the stones. Stop the film, and then you can watch how my solution looks like. Since half the stones are in the lower part of the pyramid, obviously half the stones are also in the upper part of the pyramid, so this volume v dash is just half of the total volume. The small pyramid is obtained from the big pyramid by stretching it by some factor k. So the volume of the small pyramid is k to the power of 3 times the large volume v. Since these two are equal, we get that k to the power of 3 is 1/2, so we find that stretching factor k is the third root of 1/2, and hence the height of the small pyramid is just the third root of 1/2 times the original height. The height of the frustum is the height of the original pyramid minus the height of the small pyramid, and we get in the end 0.21 times the original height. So we have found that half the stones are already used when we are only at 21% of the total height.